Hi, our first lab will be physical measurements. It is divided into 2 weeks. The week one, we will see the theory of physical measurements. Here's a summary of what we will see through this video. Types of measurements, types of uncertainties, accuracy and precision, least count and significant figures, computations with measured values, expressing experimental error and uncertainty. So our first example here is given by this picture. You can see here that we have a device which actually is useful to measure distances. Okay, this is the caliper, and actually this caliper has some, I don't know, some scales. Yes, one is the English scale, measured in inch, and the other is the international system, which here is measured in centimeters and millimeters. So what you are seeing here is a device which has something which we call the least count. The least count is indicated by here in terms of millimeters and here in terms of inches. So in terms of inches, okay, we will not use that unit. We will use the international system of units. So what we conclude here is that if it starts from 0, we will find that here we find another 0. This 0 is this 0 falls into this line. Okay, so try to see that we have a 2 and then another line indicating that here we have more or less a measurement of 2.1 centimeters. And but what about this, the least count? Least count is actually saying us that we have 1 divided by 20 millimeters, which is equal to 0.05 millimeters. So we will have a resolution in terms of centimeters of 0.05. Okay, so I will call in this the resolution 2, but usually it is called the least count. So here we have another. How can we actually put this millimeters or this count into this measurement? So let's try to see this line. This line falls here. Okay, we can say that if this line falls here, 2.1 centimeters will be measured of the height of this cylinder. But here we have also another kind of lines. We will check when those lines are aligned each other. So for instance, we can see that, I don't know, for under my viewpoint, you may have another viewpoint, but under my own viewpoint, this line actually falls are collinear with this other line. So okay, let's take into account this line. This line is actually, let's try to count. Here we have a 0, here we have a 2. 2, this line is of 0.0, excuse me, here I've committed a mistake, centimeters. This line is actually, I don't know, 0.05 millimeters. So what we are having here is 2. So let's put it the 2 here. Okay, 2. And here we have 5, 3. So here we have 3. Okay, so it's not 2, it's 3. It's 3. Okay. And after this 3, we have this other line. This other line is actually what I am considering. So here the measure is this, okay? So take into account that this is split into 1 divided by 20 millimeters, which is 0.005 centimeters. And this is actually giving us a better measurement about this height. Of course, based on my own experience here, we actually give we say that both of these lines are uh, collinear, so each they are parallel each other. But how can I actually say that they are parallel? Yes, without committing a mistake. Maybe I commit a mistake, okay, of course. So in order to take into account that I maybe commit a mistake, I need to add something here. The something which I will add here will be known as the uncertainty. Okay. So here we have something, a number. A number. I will say, I don't know. I will call this delta x, which is a number which is measured in centimeters. But take into account that, okay, depending on the measurement of the level of the degree of uncertainty, we will also define something which is called the accuracy and precision. Okay, actually, the accuracy is what will be useful to this delta x will be useful to give us an idea of accuracy. What else? We make here a measurement which is called direct measurement. Okay, this is an example of direct measurement. What is an indirect measurement? An indirect measurement is a measurement which is obtained through direct measures. For instance, what if I want to compute the volume of the cylinder? The volume of the cylinder is given by the height and pi multiplied by r squared, the radius of the cylinder, okay? The radius. Okay. So in order to compute the volume here, we need to compute or actually measure the radius of this cylinder, and actually the radius is it's a little bit difficult to measure. So instead of radius, we will use to measure the diameter of this of the cylinder. So the radius is the diameter divided by 2, and this to the power 2. So actually, in order to make measurement of the volume, we need to measure this diameter and the height. So we need uh, two direct measurements in order to obtain an indirect measurement. Okay. Okay. What about types of uncertainties or errors? Okay, there are two main kinds of errors, which is the random errors or the systematic errors. So let's try to check what is a random error. Here you are seeing that the caliper is measuring the diameter of the cylinder, but the cylinder can be something irregular. Yeah, for instance, you can see this cylinder, or maybe you can have a cylinder like this. Okay, and if you try to measure uh, the diameter, yes, of the cylinder, the diameter will depend on which zone are you evaluating. Yes. At the end, if the cylinder is flat enough to, I don't know, to give more or less an average, you will have something which is approximately to the truth. Yes, it's approximately the truth. So we will conclude more or less trying to use something which is called the mean, to conclude that the diameter of the cylinder is this quantity. But of course, This is a random error because when you are trying to measure the distance, let's try to say, let's try to make here to plot a line, which this axis is the number of measurements. Let's put here a number of measurements. And here, I don't know, the diameter. In this kind of measures, you will see the following. Here we have the truth. Yes, let's call the real, the truth. So what you will notice is that more or less the the average try to accumulate around a normal distribution here. Okay, so yes, you will have more or less this number of measurements, which will spread more or less following like a Gaussian curve, which is centered on dr. Okay. Um, of course, there is the random error here comes from the fact that we are actually using something which maybe we cannot control, which is the um, the diameter. Okay, this that the cylinder is irregular. Of course, we can maybe pick up another cylinder, but let's say that we only want that cylinder. So yes, this kind of error is producing this behavior of the points, that they tend to spread, yes, a little bit from the real our real measurement. Another kind of error could be the systematic error. The systematic error could lead us to, I don't know, for instance, of course, we know that this caliper, when is closed, um, this zero needs to this zero needs to fit with this zero here. Okay, if of course the caliper is closed. But let's suppose that this is not the case. If that is not the case, of course, what we will have here is that we know that, I don't know, the cylinder has a real diameter. Okay, this real diameter is here. The number of measurements that you are performing are given by this axis, and here the diameter that you are actually measuring. So the diameter that you are measuring is maybe false here, for instance. Actually, we have a certain normal distribution of points falling here. So the center of this distribution is a little bit displaced from the original. So this displacement actually saying us that maybe the calibration is not so good. It is not zeroed accordingly. Zero it. Yeah. This zeroed is this zeroed is the fact that we are actually need that this zero here or this zero here match with the zero here. Okay. So this is a mistake in the calibration. So it could be avoided if we maybe select another caliper which fits, which zeros fit well with these zeros here. So yeah, this can lead us to another type of uncertainty, which is the systematic uncertainty. Okay, which can be avoided if, of course, I don't know, we proceed with a different caliper. We can put here another kind of mistakes in the systematic mistakes, which can be avoided. Sometimes the systematic mistakes are committed by humans. Sometimes are errors in the devices that we are using to measure it. So yes, here we have this classification. And actually, what we are watching here is that um, the random measurements affects or has a have an effect on the precision. Okay. When we have a kind of measurement that falls into this, which lies, I don't know, close to the real diameter, like here in this example, we say that the systematic error um, have some the systematic error has some effects on the accuracy. Okay, so the ideal experiment should be one who combines accuracy with precision. Okay, uh, so what we decide our desire is that have this kind of measurements which has precision and accuracy. Okay, because the center is more or less close to the real diameter, so this experiment or this measurement is accurate. Yes, it's accurate, and also is precise. Okay, and this kind of experiment has a systematic error, which is the problem on the zeroth, the zeroth, the zeroth, namely that this zero will not fit with this zero. Okay, so this is not the ideal case, and the worst case, of course, will be one experiment will we can find, for instance, the d, the number of measurements, and it's so spread and so far from the ideal, from the original or the real diameter for here, and then this is a bad experiment. Yes. Uh, in both cases, of course, we need to repeat the experiment in order to have a better understanding of the physics or the measurement that we need to make. Okay, let's continue with least count and significant figures. Let's take this example because we already know it's very simple, of course. What we measured here was the height of this cylinder, and this cylinder was we estimate the height using this caliper, and we conclude that this is more or less the height of this thing. So what else can we do? Uh, Here we have something which we call uncertainty. Okay, so the uncertainty, sometimes the devices will say us the degree of uncertainty what we need to take in our minds when we write the measures. Okay, so but here the device will not say us the degree of uncertainty that it will manage. So we need a criteria um, to put here a number. So let me choose the following criteria. Uh, let's try to, I don't know, make like a zoom here. Okay, so we guide our measurement with this line. That was the line of reference to conclude that our uh, height of the cylinder is this. So, but we don't know exactly if this is parallel. Yeah, we have this. If this line is parallel to this line, we don't know exactly if that is what's going on here. So, okay, this line could be a little bit shifted to this other line through this way and through this way. I don't know exactly through what way this line should be shifted. So, but what I know exactly is that maybe the shift of this line if is of course, let's put this shift is of course less than 0.0025. Why I know that this shift is less than this? what is more or less 0.0025 centimeters. It's more or less this measure, okay? It's more or less this line and this line. Yeah, it's excuse me. It's dry. I draw it bad, so yeah. So here we have 2 what is this line? This line is 0. Uh, we know that here we have I don't know, like 0 millimeters, 0.05 millimeters. This is 0.1 millimeter. This is 0.15 millimeters. This is 0.2 millimeters. This is 0.25 millimeters. This is 0.3 millimeters. Okay, so if I am trying to measure this length, so here we have 0.3 millimeters. Okay, so these millimeters are yeah, I know that I am measuring this from this. Of course, if we have the two, actually we're measuring more. Then I don't know. I have to take to take into account these two. But okay, let's say that we are trying to measure just from the zero, and here we have this line. Okay, this line falls into 0.2 uh, 0.275. Okay, this line, and this other line falls into 0.325. Okay, this line. But we know that they are the parallel. Oh, here the parallel lines are here. So these lines are parallel each other. At least is where we are that we suppose that it's going on here. So yeah, um, at least the shift I know that is less than this. Okay, at least because the shift could be here and here, but always is the boundary we have here. These lines acting as a boundary. Okay. Okay. What else? So actually, the this will be the level of uncertainty that we have, and in terms of knowledge, even of this measure. Okay, we don't know if this measure is so precise, so accurate. Excuse me. Um, that of course what we are measuring here is 135 centimeters. We don't know exactly that. We need this degree of uncertainty, and if you look here, I don't know if you notice that, but this is 0.005 centimeters divided by 2. Okay, so if we don't know the level of the degree of uncertainty, we will take this, which is actually this is the last count. Okay, last count divided by 2. Okay, this is the last count divided by 2. So the shift, if the shift will be less than this, the last count divided by 2, and this will be our criteria. So here the delta will be 0.0025 centimeters, and here we have two 2.135 centimeters. But this is actually not correct. Okay, where why this the report of this result these results is not correct, because how many um, how many numbers we have here after this comma? We have 4. Okay, and here we just have 3. So the correct report should be we need to add this 0. What this is telling to us is the fact that we have information until this until this number. Okay, so after this number we don't have more information. Yes, actually we have certain degree of uncertainty in these two other numbers. Okay, so the measure of this cylinder has five significant figures: 1, 2, 3, 4, 5. Okay, five significant figures. Okay, five significant figures. Sometimes from a direct measurement, we need to obtain indirect measurements. Uh, for instance, remember this example, we have the volume of a cylinder, so we need to measure the height and the radius or the diameter in order to obtain this quantity. So, okay, but here we have an uncertainty, and here we also have an uncertainty. So we need to propagate those uncertainties. There are some basic methods to propagate the uncertainties, but first of all, we need to also sum these quantities first, the measure itself. Okay, the measure itself should also be we need to operate with this number. Okay, so in order to operate, let's try to, I don't know, to assume the following. What if I try to put I don't know, two cylinders together, and we need to measure the height or this longitude here. Okay. Okay, we need to this longitude here will be the sum of these two heights. Okay. What else? But let's suppose that here we use a caliper, yeah, a given caliper, and we use another caliper for this. Okay, we use another. Both measures were obtained using different calipers. The difference between the calipers is the scale. No, excuse me, the left count. Okay, for instance, this caliper was obtained with a left count of 1 divided by 20 millimeters, and this was obtained by 1 with 1 divided by 10 millimeters. It changes all because, for instance, let's say that we report the following measure. H1 is equal to, let's take the example of the previous, okay, the previous slide, 2, 1, 2.1350 centimeters plus something here, which is the uncertainty. And here we will have H2, which I don't know, I will assume that it will be, let's assume a different number. 2.45 yeah, centimeters. We will add here a 0. Why? Because here we have an uncertainty, and because this is 1 divided by 10, yeah, 1 divided by 10, it means that this is the last count is 0. Uh, 0.1 millimeters. in centimeters is 0.01 centimeter. Okay, so yes, therefore the uncertainty is 0.005 centimeters. Okay, so here we have 0.005 centimeters, namely if we report the measure until this number, we are committing a mistake because this other number we also give some information, which is that the uncertainty at least goes through this figure. Okay, so we have those kind of measurements. We can see that these have this measure has 1, 2, 3, 4, 5 significative figures, and this has 1, 2, 3, 4 significative figures. So in order to add these two heights, what we will obtain is, okay, we will sum this. But actually, we don't when we add, for instance, this figure with a non-existent figure here, we're saying that we don't know exactly which kind of figures are here. Okay, we don't know which kind of figure could be here in in this position. So actually, we don't know. We don't have enough information. So if we are adding something where we don't have information, for instance, let's put here an x, yes, with something where with we have information, the result is something which will not tell us anything. Okay, so what we need to report is just the sum of, okay, we will make the sum, which is I forget to make sums, 5 here and 0 with 5 5, 3 with 4, 3 with 5, 8, 5, 4. Okay, and will we need to put a 0 here? That's the question. And we actually do not need to put this 0 here. Okay, we don't know to put that because actually we don't know exactly this x, that this x is given as any information, and if we sum with the 0, it will not give us any information. So here is like we have an x, but actually we will not report that x because we don't know, and we actually will report this the result with this amount of significant figures. Okay, of course, when we add these measurements, we need to add also these uncertainties. Of course, I forgot here to put the centimeters, but okay, I guess that you understood that here we need to put centimeters here, but okay. Um, and of course, we need to use uh, these these uncertainties. Okay, the uncertainty, of course, will need to put we need to add the uncertainties. So in order to add the uncertainties, we need also take into account the level of significant figures. These zeros will not count for the significant figures here. Okay, these zeros will not count. Here we have an uncertainty with two significative figures. Okay, here we have two significative figures, and here we have just one significative figures. These zeros are not taken into account when we are reporting a significative figure. Okay, excuse me, significant figure. Okay, so yes, So what we need to do here is try to, I don't know, let's put it the uncertainty of h1 plus delta h2, because I don't want to write all these kind of things, but all you understood, guys. Excuse me if I like to put this here, but okay. So I need to sum this, okay? If I sum this together, I will need to report just once how many significant figures, just one, yeah, the one that is given here. So if we sum this, we will have 70, okay, and we don't know exactly how many are here, and maybe it adds, or yeah, it could add, and maybe it could add something to this 5. So it could be 8 or something bigger than 5. If that is the case, we need to report this with just one significant figure. And because here we're assuming this 5 with 2, we put an 8, okay? Okay, 5 with 2 is 7, but we have this 5, and if we add something which is implied here, it will sum 8. Okay, it will be close to 8. That's the correct report of a measurement, and if we are adding that, you will have a guide where you can look for another kind of rules that you may have to use. For instance, here we have a multiplication. Of course, in a multiplication, we need sometimes to make these kind of computations. That's something that you will do during this first week. Okay. Thank you for listening me. Bye bye.